let's just talk about the another concept in the chapter real numbers, which is nothing but called as the fundamental theorem of arithmetic. But before starting the concept of the fundamental theorem of arithmetic, we are now discussing the two important kind of numbers. And what are those numbers? The very first numbers, which are called as the prime numbers, and the second type of numbers, which are called as the composite numbers. As we do know about the prime numbers and what are the composite numbers, but let us suppose I'm recalling the definition of these two numbers, because in the fundamental theorem of arithmetic, the concept of these two numbers are really very important. So let us suppose I'm talking about the very first number, which is nothing but the prime number. So what is the meaning of a prime number? So any number which do have only two factors, that is a number 1 and itself, is nothing but called as a prime number. So let us suppose I am talking about a number 3. So a number 3 do have only two factors, that is 1 and itself, that is 3. So that is why it is called as a prime number. Moreover, we can talk about a number 2. It is again a prime number. The number 3, the number 5, the number 7, they all are nothing but the prime numbers, because they do have only two factors, that is nothing but 1 and itself. But let us suppose I'm talking about the composite number. So what is the meaning of a composite number? So any number which do have more than two factors, they are nothing but called as the composite number. So let us suppose I'm talking about a number 4. A number 4 do have more than two factors. Why so? 1 is the factor of 4, 2 is the factor of 4, and 4 itself is a factor of 4. It means 4 has 3 factors in total. So any number which do have more than two factors, it is particularly called as a composite number. So a number 4, a number 6, a number 9, a number 10, and so goes on. These numbers are called as a composite number. So I guess the concept of the prime numbers and the composite numbers is all clear to you, that the prime numbers are those which do have only two factors, that is 1 and itself, and the composite numbers are those numbers which do have more than two factors rather than taking 1 and itself. So this is nothing but the prime numbers and the composite numbers, or the discussion which is related with it. So let's just move on further toward the fundamental theorem of arithmetics concept, which says that let us suppose I do have a number that is 1178. So let us suppose I have a number 1178 and I just wanted to find out the factors of this particular number. So in order to find the factors of the number 1178, we just have to start dividing the number 1178 with the least prime. So let us suppose I am dividing the number 1178 with the number 2. So let us suppose I'm starting dividing the number 1178 with the number 2. So when we will divide 1178 with the 2, then we will get the quotient as 588, because the number 1178 is totally divisible by 2. So the another factor or the quotient we will get is nothing but 588. Again, when we will divide the number 588 with the number 2 again, let us suppose we are dividing it with the number 2 again, then the quotient will be like 294, and this particular quotient is again, let us suppose I'm dividing it again. So furthermore, when we divide or with it 2, then the quotient will be nothing but 147. So we will continue the whole process again and again with the numbers, that is the quotient that we are getting every time. So let us suppose I am dividing 147 again with the number which is nothing but 3. So let us suppose I'll divide 147 with the number 3. The quotient that I will get is nothing but 49. Again further, when I will divide the quotient 49 again with the number 7, then I'm getting the answer as nothing but 7. So here 1178 do have a factors which are like 2, 2, 2, 3, 7 and 7. So we can write all this particular factors or the division in the formation like 1178 is nothing but is equal to 2 into 2 into 2 into 3 into 7 into 7. So this is nothing but the factorization of the number 1178, and sometimes in the earlier or in the previous classes we call this particular formation as a factor tree, in which we are basically finding out the factors of the number 1178. So here we are getting the factors as 2 into 2 into 2 into 3 into 7 into 7. So what is the thing that is common in between all these factors is that these factors are nothing but prime numbers. These factors are nothing but prime numbers. Obviously 2 is a prime number, 3 is a prime number, 7 is a prime number, and it means that any number of the formation 1178, or if I'll say any natural number that I do have, must have a factorization of this particular formation in which the factors are always called as to be prime numbers. So it means that, or we can conclude a thing from it, that any natural number can be expressed in the formation of the product of the prime numbers or the factors which are basically prime. So this is all about the fundamental theorem of arithmetic, which says that any natural number can be expressed in the formation of the product of the primes, or we can say that the factors of it are nothing but the prime numbers which are uniquely expressed. So this is all about the fundamental theorem of arithmetic. But let us suppose we are concluding that particular concept from the this particular example, but let's just move on further and we will furthermore talk about the fundamental theorem of arithmetic, and we will see the definition of the fundamental theorem of arithmetic.